All right, hello, can you hear me?
Yes.
All right, hi everyone, I'm Melanie from Airbnb, and I'm here to talk about how we're moving from a monolithic to a microservices architecture. Cool, so first off, what is Airbnb? Who here has heard of Airbnb? Okay, perfect. Well, I'm just gonna give you a little bit of a reminder. So Airbnb is an online marketplace for sharing homes and experiences. We operate in 65,000 cities in 191 countries, and this summer we reached over 4 million listings on our platform. Recently, we had the largest ever response to the activation of our disaster tool for Hurricane Harvey, with over 1,000 hosts opening their doors for people in need. Yay. So, a little bit about me. First of all, I have a friend in the photography department, obviously. But seriously, I work as a software engineer on the infrastructure team at Airbnb. I currently lead SysOps, which is a volunteer group of engineers who serve as first responders to keep our site up and running for our employees, guests, and hosts. In addition to working on instant response, I spend most of my day working on improving developer productivity. So I work as an engineer on things like continuous deployment at scale and enabling the easy, reliable creation of microservices. So yeah, in terms of scale, this summer alone, we had 45 million guests stay in an Airbnb listing, reaching a total of 200 million guest stays since 2008. And in terms of engineering, I think just last week we hit about 900 engineers internally. So we're hiring really, really fast. So you start to reach challenges at this point where we want our engineers to move very, very fast, but we want to keep our site up and running for everyone that uses it. So we basically want to have 100% availability, and we also want 100% productivity. So 100% availability means that our site is completely available for our guests, hosts, and employees. And 100% productivity means that everyone in product can easily create, change, and release features. So yeah, this picture is a Venn diagram. Yep, there is literally no overlap between the two. You have to make a decision. So at Airbnb, I would say that we do lean towards productivity. We want to, because we're still a startup, we're trying to iterate as fast as we can. But at this point, it's very important that our guests trust our features. So trust is very important. So we try to balance these two things. So our time together today, I'm going to give you a brief history of the origins of our DevOps culture and how that shapes the tools that we use. Then I'm going to switch into talking about the challenges we faced as we tried to scale monolithic deploys and all the tool changes we did there. And finally, the focus of this talk, how we're actually making the move to microservices. And hopefully I'm going to give you some tips that we had to learn the hard way. Cool, so a brief history of Airbnb. We have a monolithic Ruby on Rails application that we've nicknamed Monorail. This is a little monorail in the background. We're not very original. Other companies also use this. I think they maybe joined our company and then decided to use the same name. So yeah, Monorail is our monolithic code base. So sometimes I'll say Monolith and sometimes I'll say Monorail. Basically, this means that when we started out, all of the code for our website, from the user interface to the backend that accesses that data, it historically all lived in one repo in GitHub. So yeah, Monorail, one GitHub repo. And originally, back in the early days, before I joined the company, we were pretty much only hiring product engineers. So we hired one person to handle all of the systems and operations, and this was our first SRE hire. However, as Airbnb scaled really dramatically, this person quickly became on-call 24/7. So one day at an Eng meeting, this SRE stood up and said, hey, I'm having a really tough time. I'd like to go camping this weekend, but I never can. So can anyone step in and help me out while we're trying to scale everything? And at the meeting, several other engineers stood up and said, you know what, I'm willing to help you out. So there was no real requirement for these engineers except for this willingness to help keep the site up. So we had engineers from all over the stack. In fact, primarily at the beginning, more front-end engineers and back-end engineers, trying to learn how to operate our systems, step in the case of disaster, and generally just share the pager. And this group became SysOps. So this is the group that I currently lead today. So you can see this kind of containing the fire. And what we didn't realize at the time is that SysOps became a really unique and strong part of our culture that has really helped us out today. So what does SysOps do? So SysOps have 3 main responsibilities in the event of an incident. If the site is down, the SysOps are the first to triage the problem. So basically, site-wide alerts for elevated error rate and business metrics get routed to SysOps directly. We also keep an eye on everything, so if some people report internally the site is having severe issues, we'll also triage in that case. So next, SysOps coordinate a response. Sometimes this involves taking remediation steps directly themselves, but as our business has evolved and become more complex, remediation often involves escalation. So SysOps will escalate to internal service owners, to product teams, to different infrastructure experts as we've hired them, and to third-party service owners. Finally, we communicate out a response. So this could be anything from telling our social media team to send out a corrective tweet, to locking deploys for all of our applications if there's a severe outage, like with monitoring and alerting. Cool, so over time, this SysOps group has evolved and rather unexpectedly became a huge lever for cultivating a DevOps culture at a historically product-driven company. And this becomes really important later on when you're trying to scale to microservices. So for the SysOps rotation itself today, we allow anyone who has taken this basic all-day SysOps training class to join the on-call. So SysOps is a really effective way for an engineer to learn about our architecture and systems at Airbnb, and to practice incident response in a very hands-on way. So currently, we have over 40 engineers on this rotation. One thing we do a little bit differently is we have 2 primaries that we call SysOps buddies, so you're sort of paired together. So new SysOps shadow more experienced SysOps, and we like to encourage them to work together directly. So they're both sort of solving the incident together, or maybe like one of them's handling communication while the other one is trying to solve the incident. It's also extremely scary if you get woken up at 3 a.m. and the site is down and you're by yourself. So we found it's very helpful to wake someone else up with you. We also added something fairly recently, a few months ago. We have both a weekday and weekend shift, so SysOps can choose whichever works best with their schedule. Cool, so I'm going to talk a little bit about our SysOps training. So originally, this SysOps training was just for engineers that were interested in joining SysOps, but we've actually opened it up to all of engineering, and it's become quite popular. So we try to run it once every quarter, and it's basically how we establish best practices for on-call and incident response. So engineers that attend, so there's a few sessions. They learn about infrastructure, our current architecture and how it has evolved over time, how to set up an on-call for their team if they're interested, how to be an effective on-call. And we also have a hands-on lab session where everyone gets paged, which is really fun. So that's always a highlight. It's like, oh, I got paged today. So at least 33% of engineering has attended a SysOps training. And that number basically is always out of date because we hire engineers exponentially. So we're sort of shooting for 50% by the SysOps training this quarter. We also encourage service on-calls to escalate to sysops. So we want to set new services and new teams up for success, and they may not know the best practices going into it. So we want to let them know that we're a resource for them and to encourage them to sort of jump in. Finally, sysops tries to push for a blameless postmortem culture. So instead of blaming the individual when something catastrophic happens, what we really want to do is find the systemic issues and fix them to truly prevent these incidents from happening again. Cool. So with the sysops group and sysops training, we've cultivated a culture where every engineer can individually build, test, and release their software frequently and reliably, and this is called DevOps. So we expect all engineers to be familiar with every step of this figure-8 cycly thing. Cool. So because of our approach to DevOps, we need monitoring and alerting that anyone can use. If you look closely at this slide, you can see an error spike in the background, so hopefully everyone knows what that means. Something bad happened. And so we use New Relic for this. So yeah, this is how we monitor our site. We have these orbs, and they light up with different colors. So green means the site is up, and red means the site is down. So yeah, no, we didn't actually, so we did build these, but it was more for like a hackathon. So some sysops have these cool glowing orbs on their desk. It really helps build our brand. And they're actually pretty advanced. Like they take in stuff like New Relic error rate and like have synthetics and stuff. But this is not actually how we monitor the site. So we use New Relic everywhere. So for Monorail, we're adding it to our backend Java services, any of our internal applications. We're using browser, and we're recently trying to add support for mobile apps. So that's coming really soon. Basically, as we add more and more teams with different approaches and different code bases, we want an engineer to be able to go from one application to another and their suite of tools to be the same. I'll talk more about how we integrate New Relic with our tools in a couple of slides. Okay, so how do we actually monitor? So we use the statsd protocol. And this is so that we can automatically collect system metrics. This is really huge. Anyone that sets up a new service will automatically get system metrics routed to them, like super high CPU usage, stuff like that. Something that's also really important is that we want engineers to be able to write metrics live alongside feature code so that they can write their own business metrics. So if you were like sort of counting how often some event happens and that drops to 0 and like that never happens, you can alert on that. So it's also easy for any developer to write, and that's the important thing. If engineers don't understand how to do something, they're not going to do it. So that's why we sort of built it into their process. You can open a pull request with a feature change, and you can also add some metrics. Or maybe the pull request reviewer can be like, hey, you should add tests, and hey, you should add metrics. Finally, this gives us something that's really important. We want service-level dashboards so you can get a high-level overview of a service with both the business metrics and system metrics alongside each other. So you're like, I know there's something wrong. I don't know exactly what it is. I'm going to look at the service dashboard, and I'll have a really good idea what is wrong, usually at that point. So we also built a little bit on top of this. We have alerts that are configured as code. So we came up with our own DSL for writing alerts based on these metrics. So this is an example right here. Creating a new alert is as simple as opening a pull request. We also use automatic alerts set up with New Relic for the biggies. So like elevated error rate, response time, stuff like that. So whenever possible, we try to give things to developers for free. So now I'm going to transition into talking about some of the challenges scaling a monolith and transitioning to microservices. So Airbnb started with our monorail, and this worked really well for a really, really long time. But, this is a big one, we started running into huge challenges with scaling this deploy process for Monorail. Not only was it frustrating for developers, we would actually attribute downtime to this process, where people couldn't get fixes out fast enough, or they couldn't roll back properly, stuff like that. I think it's important to note that I don't think anyone should start out with microservices. I would consider that a pre-optimization. So like when Airbnb just started, maybe we weren't going to survive another year, so you really shouldn't be investing in infrastructure that heavily at the time. But when you do start out with the monorail, you also need to know exactly when you should start making the switch over. Like at what point do you invest in microservices? Because it can kind of sneak up on you. So when does it start to become a problem, Melanie? So this is our monorail lines of code. We are on track to hit 4 million lines of code in one code base. I would say we started to realize it was going to be a problem in 2013. So we were about to hit 500K lines of code, and we saw the rate was starting to look kind of like a hockey stick. And we're like, okay, if we're doubling our lines of code every year, this just isn't going to scale. So it's important to have that insight pretty early on and start building the components required at that point. So we started in 2013. So this graph is still kind of scary looking, but actually since we've been hiring engineers exponentially, if you divide this graph by the number of engineers we have, the growth is actually slowing down. So it's a bit more logarithmic. I just didn't have time to do that operation, so plus this graph looks cooler. Today we have 900 engineers, and we still have to invest a lot in scaling this process because we know the transition takes time. So for context, I believe Netflix gave a talk somewhat recently, maybe a year or two ago, and they said their transition took them about 10 years. So, hopefully we'll beat them. I don't know if there's any world record, but we're making progress, but it's going to take time. We know that. So this is still a problem because with 900 engineers and a lot of them working in new services, we still find that 300 engineers, so about a third, still have to make a change to Monorail once a week. So a lot of the code still eventually goes back to Monorail at this point, and we have to continue to scale this process for these people. Cool. So we developed an internal tool. It's called DeployBoard. This is DeployBoard right here. So DeployBoard is a tool we built to help developers reliably test, build, and deploy their code to production. When changes are merged to master, they automatically show up on this dashboard. There's a lot going on here. So basically, there's the changes on the bottom. These are all different SHAs. We have the new outgraphs, and then we also have the different deploys going on. And then at the top is how you can navigate to different applications. So at Airbnb, we have an internal term we use for our deploy process, and we call it democratic deploys. And this philosophy means that every developer is expected to own their change from development to production. And this sort of differs at some other companies where separate people are the ones shipping the code. So yeah, all engineers are expected to own their feature from implementation to production. And what that means in practice is they're expected to do the deploy, monitor their changes after the deploy, and roll back, abort, or revert if necessary. So we've designed the interface to really help engineers do this. So every major action in DeployBoard is a push of a button. If it's any harder than pushing a button, you're going to have problems. So aborting, rolling back, deploying, reverting, everything is a button. One other thing that was really important that we started to realize as we added more and more applications was directly embedding our graphs into this interface. So when you press your button that deploys, immediately in real time, you can't even look away. I mean, I guess you could look away, but it's right there. The graphs will show you if there's something wrong. And that's been really helpful. So as an engineer, and this has happened to me many times because I'm not perfect, I deploy my code and I see the error rate shoot up. I know there's a problem. Usually I'll just stop the deploy right there. The key thing then is there's something wrong, you don't know what, so we encourage developers to then switch over to New Relic and actually look at stack traces, error analytics, stuff like that to actually dig into what was the root problem. So the interface and the process for deploys at Airbnb is designed with continuous delivery in mind. That means that each change that is merged into master is deployable to production. So you want a really solid continuous integration system. We also encourage frequent deploys with smaller batches. So this means that we deploy monorail about as fast as we can, which is 1 to 2 times an hour. And all other applications can be deployed much faster. So lots of frequent deploys. We allow deploys 24/7. So we automate as much as possible. And we've done some other stuff as well. So build, tests, and deploys must be fast and reliable. Where I see a lot of companies struggle is tests start to get really flaky. That means a developer doesn't know if their test passed or failed, if it was due to their code or not. So that's really scary. You'll want to invest in tests that are 99.9% reliable. We ping authors whenever they need to take any action, so we use Slack for that. We did a lot of work to make reverting instant, so they don't have to wait for CI or anything. We created a merge queue. So as we added more and more developers to Monorail, we started to get into a problem where we couldn't enforce small batches of deploys. So we started getting deploys that had 100 changes in them, and this is not what we wanted. So the merge queue will people will just sort of put themselves in line. It's very orderly. It's a queue. And then we will actually automatically decide whether we're going to merge the next batch of changes in for them. We also invested in automatic rollbacks for new exceptions. So this doesn't catch everything, but this really, human beings are kind of slow, man. So if you can have robots do it, it's really cool, and it's really effective. So that was about as far as we could take it. And that brought us a lot of time. But we knew that at some point we had to switch our strategy over to really making microservices work and be great. All right, so it's definition time. What are microservices exactly? So I don't know if there's an official term, so I just stole something from someone on the internet. So we consider them to be independently deployable, small modular services that each run a unique process and communicate through a well-defined mechanism. Basically, instead of having one service, you got a bunch of them, and hopefully they're smaller. So why not microservices? Well, you get 2 of the hardest problems in computer science for free: distributed systems and naming things. So we today have over 300 services, and naming starts to get pretty interesting. Developers are getting pretty desperate when they name their service Eggplant. But in practice, one of the other hard things is having to support different languages and frameworks. And this kind of sneaks up on people. For us, the drawbacks became worth it. So I've already talked about this. We knew we needed independent deployment. One thing I also really want to drive home is when you have a code base with almost 4 million lines of code, ownership becomes extremely difficult. Tech debt starts to get pretty bad. There's no modular structure that's enforced because the code base does everything. And so this makes it really difficult to define ownership. It makes it really difficult to have teams try to have on-calls when metrics are affecting multiple teams, stuff like that. Finally, for us, security and performance started to become really important for some of our code paths, and we just couldn't enforce it well on this code base. So we started to have some compliance requests, SOX compliance, PCI compliance, And it's really, really nice to be able to say, yeah, so all of our code for that lives in this other service, and that service has all of these nice features. And then we're not trying to do that for a humongous code base. On a similar vein, upgrading dependencies becomes nearly impossible, or possibly even impossible, for a monolith. And so when we were rolling out our Ruby upgrade, doing it for a service was like a snap. Doing it for monorail was a long and difficult process. Basically, we wanted to scale continuous delivery horizontally. So like instead of having one big continuous delivery pipeline, we have a bunch of nice, small, self-contained continuous delivery pipelines. All right, so that's a nice graph, but what does this look like in practice? So this is our deploys per week, all apps, all environments. So there's 2013, before the time of recording. And then, whoop. So we basically support 3,500 deploys per week. And you might be wondering, what are those big drops in the graph? So we actually have a holiday break every year, and we don't let developers deploy during that break. So those dips are developers enjoying their break, and also we don't want to ruin Christmas for anyone. So yeah, no changes. And what this basically amounts to is 75,000 production deploys per year. And that is not even possible in our monolith. Cool. So what is the bare minimum needed to build a microservices architecture? You need configuration management. So we use Chef primarily, and we're experimenting with Kubernetes. You need a way for services to register and discover each other. We use SmartStack primarily, and we're experimenting with Envoy. And you need a message bus for services to communicate with each other. And we use Kafka. There was actually a good talk about using Kafka the other day that I attended, which was really exciting. So we also have some stuff built on top of that. Cool. Some other stuff that you'll probably want that we also developed is a way to rapidly provision instances. So we use AWS for that. You want a DevOps culture. You don't want to be in the business of one ops team trying to run ops for hundreds or thousands of services. So however you cultivate that, just make sure you're investing. Basic monitoring and alerting set up for every service, and continuous delivery. And what we found is we were building a lot of these things for monorail anyway. We just wanted to make sure that when we were doing that, we built it in such a way that we could just also use it for whatever services we had later. So, moment of truth. Basically, we built all of these requirements, and it was time for our first service. And that service really led us to question whether we were committed to microservices. The service was clunky, wasn't really a microservice, we didn't draw the service lines very well, and the service communication piece wasn't working that great yet. And so I just want everyone to know that your first service is probably going to be bad, and that's okay. We didn't know that at the time, and I think we struggled for a few months trying to decide whether this was like really the right path. So just know like it's going to be a bumpy transition. And I think we've made that transition. So we have 900 developers, 300 services, about 4,000 deploys per week. So what are the challenges? Supporting different languages and frameworks, as I said. So we try to limit. So some companies will sell microservices by saying, just use whatever language you want. Go crazy. It'll be fun. Engineers love this. Yeah, so then you have to build support for all of those, and it's really not so fun anymore for the people trying to support it. So we try to limit ourselves to like a very small set of languages, like Ruby, Java, JavaScript, like trying to keep it simple over here. But then like you sort of like acquire a company, and they use Python, and then you have to sort of support that too. So it'll find its way creeping in on you. One thing to quickly point out is we also had challenges with scaling our database. So we started out with one database as well. So when you break things out into services, you'll also want to be splitting up your database. And then each service should own their own data, and they should use the message bus to, in a standard way, communicate to the other services that there's been mutations to data. Standardized configuration starts to become really important. You don't want every service to behave differently. That's like a nightmare. And developers will insist that their service is special. Monitoring with microservices starts to change. So you might start to see your service behaving badly, and it's not actually you. It's a downstream or upstream, whatever service that is affecting you. So you want to be able to have services recover in these situations, so you should be expecting failures. And you just want to improve your monitoring situation to handle that. Finally, splitting the monolith is a real challenge as well. I'm going to talk about that really quick. So we basically have Monorail. It's a big box. We have a core booking flow that used to be like 4 pages, so we called it like P1 through P4. Obviously, not really a great candidate for big, huge microservices, so we didn't want that. So the way we started to think about it was that there'd be a UI layer, and that UI layer would talk to the API layer, and that API layer would then talk to all the different functionality. And functionality has vertical concerns and horizontal concerns. Vertical concerns is more like business stuff like calendar, availability, pricing, and horizontal concerns is stuff that's sort of used by all other services, security, encryption, decryption, translations. So, I mean, yeah, it's just a way to think about it. Cool. So the UI layer, basically, we have our front-end code still in Monorail, and we also have a separate code base for our mobile apps. And then we sort of have started taking out pieces of Monorail and turning them into their own little microservices. And the API layer can either direct traffic to Monorail, or you can switch it over to talk to one of the services. So we sort of have like a migration path for switching out code. Just a reminder, no snowflakes. So as you're breaking out these services, make sure that you are starting to think about what do they all have in common, what should they all have, can we build our configuration to support that? So yeah, application as code is very important. So we want it to live as code inside the repository for the feature code. We want it to be automatically tested and validated as part of CI. And we want it to be deployed and consumed as an artifact. So it's basically its own little build. We also have a standardized format and defaults. So the easy thing is the right thing for developers. OK, so maybe you fell asleep in this presentation. That's OK. Wake up right now. This is the important slide. So what are the 10 takeaways we had as we make our way through this transition? So Monolith first. Monolith did work for us for a very long time, but we had to know when should we make the transition and how are we going to do it. And so we had to formulate a plan to move to microservices and then execute on that plan. DevOps culture was really huge. You want each engineer to be prepared to support their service, because right now we have a ratio of 3 engineers per microservice, and it's going to continue to grow. So other companies, they have microservices even sometimes outnumber engineers. Configuration as code became really important. Developers aren't very great at trying to keep track of all these tools, and the data isn't clear to them. Developers do understand code, and so if you have your configuration as code, it's very easy to reason about what configuration is currently in production, whether configuration has been rolled back, making changes to configuration. It's all right there for them. Monitoring and alerting, you want to have set up for every service. So using a standardized tool like New Relic is extremely useful. So developers will monitor and alert the same way, going from one application to another. Continuous delivery, you'll probably have already started to invest in this. It's very difficult, it's a hard process, scaling deployment for a bunch of engineers. But if you've gotten this right, every new service that's created will have the same process and the same benefits as the monolith. Automate whatever you can. And that's because manual steps are very difficult and error prone. Your first service is going to be bad. So just keep this in mind. It's one of the reasons it's the top 10 is when you're actually going through this, it's still very challenging, and you have to remind yourself that everything's going to be okay. Services own their own data, so that's what I was talking about with sort of scaling the database piece and how services communicate with each other. Break apart the monolith. So at some point, you're going to have a bunch of new functionality being created in new services, and it's going to be awesome. And then you're going to realize you still have millions of lines of code stuck in your monolith, and you're going to have to work with product teams, right? So maybe your infrastructure team was sort of in their own corner building out this cool microservices architecture, and then at some point you have to be like, you have to convince product engineers to work with you, to break apart the monolith, and then you can show them like these really awesome graphs about how they can just deploy whenever they want and be really fast and it'll be awesome. But you have to really invest in this. And so this is sort of where we are right now, is we're working with our product teams to actually break apart the monolith and slow down its growth. And the other thing we're still working on right now is that standardizing service creation piece. So we want people to be able to create a service with one pull request. So all the configuration is right there. You create the repo, you create the configuration. For us, the ideal thing is that you also only need to define stuff that's unique about your service. All right, those are my 10 takeaways. Thank you.
Great presentation. Thank you very much. Questions? Would you repeat the question after they ask you rather than?
Yeah.
Okay, go ahead.
So I have two questions actually.
Okay.
The first one is you still deploy monorail, right?
Mm-hmm. Yes.
And how do you have each team monitor their own part of the deploy of the monorail? How do you divide the dashboards for each team in the monolith?
Okay. Yeah. So the question is, we still have a lot of engineers deploy using monorail, and how do we have them monitor their different changes as it's going out? That one's very tricky, and I don't think we've gotten it quite right. Engineers have missed things. So we do have on the top layer just like the very top level stuff like error rate and response time. And also we use rescue, so the rescue error rate as well. Each team also owns usually their own dashboard for their changes and monitors and alerts on them. We don't have a really great way to like enforce that. And so that's the nice thing about microservices is like maybe those top level graphs or the top level dashboard for that service is like, it's just like one team, one dashboard. But we don't have a great way to say like, yeah, monorail probably has like 50 dashboards. We can't really like show them for everyone. So yeah, it's usually set by the team.
So my second question is not related to monitoring.
Mm-hmm.
But when you have, we have the microservices, right, in your dev environment, how do you develop your own service? But it might touch other services.
Yes, yes. Great question. So I didn't really talk about development that much. When you have 300 services in development, how do engineers develop it when like these services are talking to each other? So we've got a really big effort underway that services in development act very, very similar to services in production. And so we actually have, we started out historically, developers used Vagrant and like VirtualBox locally. And what we ended up doing is we like moved to the cloud. So your developer instance is an AWS instance. And that was because we started to run into really huge CPU and memory issues. So that was the original idea. But we can actually build on top of that. On the instance, all of the services that are enabled can actually talk to each other. So when you're making a change to one service, you can also like test how that interacts with the other service.
So everybody will share a pool of the common services and you only change the one that you care about?
Yeah, so we have like a list of roles you can enable. So whatever services you want to be changing are the ones you enable. So we don't enable all of them by default, just because like some services are more like, they're not quite set up well for development yet. And so our vision is that you'll have like a pocket universe that is similar to production, but in development, where everything's sort of talking to everything else. And we've made really good progress, but I would say it's maybe like 50 services are in this yet, so it's not all 300. Question?
Yeah, kind of on that same note.
Yeah.
Do you have one feature that requires changes to multiple microservices? How do you ensure that they're both like delivered at the same time and you don't have one that's
Yeah.
that's causing an issue with the previous.
So we basically enforce that every change has to be backwards compatible so that you don't try to time stuff. We're also really investing in this standardized service IDL where every service has a standardized API and client. So when you're making a change to the API, it's like it still works. So we basically have asked the developers to be backwards compliant. It's extremely difficult in practice. And so now we're trying to enforce it just in the code. Yes?
So call back to the sysops when you had the one guy who wanted to go camping.
Yes.
And you decided to rotate through. Just to kind of paint the picture, are you talking about like one main website and a bunch of back-end services or things that support it? Or how big was your application portfolio? And has it really changed, or you kind of like split it up into microservices?
All right, so the question is when we had like one SRE and they were asking for help, what did the like landscape look like?
Yeah.
So this was certainly before I started. I think that was probably 5 or 6 years ago. But we basically had at that point just one repo. We didn't have any microservices. That was before that. And what was the second part of the question?
It's really how many applications were there to support?
Yeah, it was just one at the time. So that's why sysops has changed so much, because we're not just supporting the monorail. We're trying to be more of this like fallback for all of our services.
You had the brilliance to create that one template that everybody followed through and did it the same way. Because that's, to me, brilliant.
Thanks.
Today, when we rotate through, everybody does things a little bit different way, and you end up with mixed results, and it doesn't scale.
Yeah, standardization is the only way to scale. All right, there was another question. Yes?
So I kind of 2 questions. So on the, we'll call them legacy services on Monorail 1, your web routing of the calls to, say, a legacy calls for the fallback versus your microservice container
Yeah.
lines. Was that something that you did all in your site as the main thing, or did you do some sort of routing saying, if this URL gets called, we're going to rewrite it and send it to the main?
Yeah, so the question is when you're thinking about this API layer and how you're routing stuff maybe to the monorail or maybe to another microservice. So that API layer, I believe, has historically been in monorail. We're actually building out an improved API layer that will be kind of like a separate service, and it will actually be, so one problem is our API layer, because it was in monorail and our monorail application is pretty slow, is when you're trying to route stuff to a service that needs to be fast, you're having a huge time penalty going through monorail. And so what we're doing is we're rebuilding it at the load balancing level, and so that it'll be really fast.
And my second question is, when you implemented the instrumentation for New Relic, you put it into the microservices? Like the agent component for that, is that also in the container, or is it that you're just using external data injection?
Okay. So I don't think, one thing we're lacking right now, so the question is how do you like use New Relic? Like do you have an agent or something? Right now we're not very standardized and consistent about that, so we're trying to get to that. So, but ideally it's like an agent that's just like automatically set up for you. Right now developers have to sort of go in and like set it up, and how they set it up, I don't know. So we're trying to standardize on it.
So you have a separate agent within every container or microservice, and then they
Yeah, so realistically right now, most of our microservices are not backed by Kubernetes, and they're not containers. But we're transitioning a lot of them that's the direction we're headed. But I would say like the majority of them are still like we're using like Chef. It's not technically a container. Yeah.
jars of code URLs and paths right now.
Yeah. So yeah, it's just like bundled up code.
You're not in port hell.
Yeah. No. We have had port hell. So right now, most of our port, like the port registration is like a Chef file, and we've got thousands of them are being used at this point. Did you have a question? Okay.
Can you go back to
Yeah, does this thing go back? Okay. We only go forward. All right, yeah, so this is the slide. Maybe time for like another question? Yes?
Do you guys run for like consumer contract tests between services?
Yeah, so part of this standardized API client between services is that it will enforce the contract. I don't know if they've added any testing or not to like actually enforce it. But the API you're given is standardized between all of them.
You said that you plan on retiring Monolith or monorails at some point. Is that true? How do you have a process to isolate, like to highlight part of it, figure out how to carve it up, and then do you delete the code, or do you retire that project again?
Yeah, so the question's about splitting the monolith and if we're going to deprecate it. I would say that we're still at the beginning of that process, and we haven't really gotten to the point where we plan to have no code in monorail. Like the UI layer is still there. So we're sort of forming a separate plan for like separating out the UI layer into another service, and then we can really start thinking about like deleting like huge red diffs. Yeah, so that's sort of like WIP. All right, I think we're out of time, so thank you everyone. You can talk to me on Twitter or whatever.